I'm Jeff Ichnowski. I'm an incoming professor in the Robotics Institute. The main area of my research is in robotic manipulation, where I like to tackle difficult problems such as those involving dynamics and deformable objects. I focus on deep learning and optimization methods. I also research cloud robotics. The goal of my research is to increase the capabilities of robots so that they can help with more tasks in our daily lives, whether it's in logistics, manufacturing, at home, or in healthcare settings. I'll describe 3 areas of my research and then discuss some of our current limitations and how that will lead to future research interests. The first area is fast dynamic manipulation. In many settings, speed is critical for success. In prior research, we explored speeding up pick and place by integrating grasp, motion, and time planning. We found that a robot arm moving too fast while transporting something can lead to spills and broken objects. We explored integrating constraints based upon the dynamic state of the robot. We used this to keep contents in a container during high-speed transportation, and we can show that varying the tolerance can allow us to move objects faster. We can also use these constraints to compute motions that transport objects upside down without spilling. This approach allows us to transport liquids without spilling too. With this groundwork, we can also explore dynamic planning with difficult-to-model constraints, such as suction cup grasps that break with high acceleration. We showed that it's possible to learn complex constraints offline and integrate them into online trajectory optimization, allowing robots to transport objects safely and at high speed. We also explored how to dynamically manipulate deformable objects. In this example, we showed that a robot can extend its reachable workspace well beyond its rigid structure. One particularly interesting aspect of this research is the hypothesis that dynamic manipulations are not only faster, but sometimes more robust than quasi-static ones. I also researched learned optimization. We're in an exciting time where deep learning demonstrates remarkable capabilities, but in robotics in many domains, optimization is still the best choice due to its strong mathematical guarantees and precise constraint satisfaction. I'm interested in finding ways that combine deep learning and optimization to gain the best of both. For example, here we outline how we used reinforcement learning to speed up quadratic program solving. In that case, we sped up the solver by 3x. Cloud robotics is another key area of research I explore, often in collaboration with systems researchers. Robots are constrained by their embodiment. If a robot wants to navigate the room, it can explore options using a sampling-based motion planner using its onboard computer. With the cloud, robots can simultaneously explore on hundreds of computers or even thousands of computers and gain speed up, sometimes for just a few pennies of compute. While there's an algorithmic side to this research, there's also a system side in which we aim to address the question of how to streamline cloud computing for robots. One way that we've proposed is by facilitating automation of cloud deployments of compute-heavy nodes. For example, if a robot has 2 compute-intensive nodes, with a few changes to robot software configuration, we have a system that moves the nodes to the cloud, allowing for significant computing speedup. So moving on to some limitations and future research and collaboration ideas. One key limitation is demonstrated here. Many of the properties of the held object are difficult or impossible to model. I'm interested in exploring ways to sense or learn these properties of objects quickly, such as friction or adhesion properties, or mass distribution. With such properties, robots would be able to operate faster and more robustly. In robot learning, a critical component is data. I'm working with students to create a cloud robot learning platform that will enable the next generation of distributed robot learning algorithms. To round things out a bit with additional past and ongoing research projects that are of interest to me, we have superhuman speed surgical robotics, mechanical search, transparent object sensing, grasping, and manipulation, rope untangling, and multi-object grasping. If any of the research topics I've discussed here interest you, please feel free to reach out to me. Thank you.